Welcome. Last class we got moment of inertia for area in the form of a circle or circular cross section. As if you remember, answer was whether irrespective of whether you consider x-x axis or y-y axis, both will pass through center. Answer is pi d power 4 by 64 in terms of diameter or pi r power 4 by 4 in terms of radius, where xx and yy both are actually diameters. See, you can make out for circle. Both, see, I told centroidal axis, xx, yy, see this way, xx and yy. Actually, they are also diameter. This is already over. But what I have done is, when I derived the equation for moment of inertia by second time, that is option 1, when I took, see, first I took, if you remember, this very important concept solve, see, I took circular area. Then I took a small elemental arc length here, radial distance r, angle theta here. Then I got I about this axis. How much I about, I write here now, I about this axis I got pi r power 4 by 4 in terms of radius or pi d power 4 by 64. This derivation was done. Then this was for full circle. Then I told, in case it, see, if you remember, the integration limit was theta 0 degrees, degree is not allowed. Theta equal to 0 to theta equal to 2 pi radians. Full this way. See, this is the elemental arc. Okay. Then you make a note, put this sketch. It's very, very important. Then I considered semicircle. See, I removed this one. See, these all arrangement will remain same. Semicircle. At that time, theta integration limit is 0 to pi radians. Then your answer came pi r power 4 by 8 and pi d power 4 by 128. This is the answer we got last time. Then what I told is, I consider a quadrant. See, again, I about this axis only. See, I never talked about centroidal axis there. I about this axis. Theta limit is 0 to pi by 2. Then I got pi r power 4 by 16 and pi d power 4 by 256. This answer we got, or all are derived. Okay. Now, make a note of that one. It's important, this result. Now come to moment of inertia for a semicircle or semicircular area or area in the form of a quadrant of a circle. For both, to save the time, already earlier so many times I told, let d be the diameter and r be the radius. Okay, then see, semicircle here. You write, I don't have to write. I think, shall I write here? Actually, not required. You write here. Semicircle. Here, quadrant of a circle. If it is semicircle, this is diameter. Okay. This is radius r. R equal to d by 2. Undoubtedly, here r equal to d by 2. If you take quadrant of a circle, see, then this is quadrant, diameter d. Diameter you cannot see, but diameter is there, you cannot see it. Radius r. There also radius equal diameter by 2. Why? See here, semicircle, I will do one thing now. I will tell one more thing. Let C be center of the circle for which above 2 are either semicircle or quadrant of a circle. Okay. Then center is, see, semicircle, center is here. This is center of not semicircle, center of the circle for which this is semicircle. See, semicircle here. Continue, you get circle here. See, for this circle, this is center. So, in future, if I mark the center of the circle, understood that, see, someone will comment, Sir, you told semicircle and you are talking about circle. Center, if I tell C, center of the circle means it is center of the circle for which our considered area is either semicircle or quadrant of a circle. So I will make a note here. In future, I won't waste time every class. In future, whenever I tell center of a circle, center of circle, see, circle, that is C, it means you write a note here. In future, should not argue with me, not bargaining, will bargain with me. If it is circle, yes, it is center of the circle. Diameter you can see, radius you can see. If it is semicircle, then the C means center of the circle for which our area considered is semicircle. Extend other side, circle will come. See, circle will come. For this full circle, center. Semicircle also, you can see the diameter and see the radius. Whereas, if our discussion is for quadrant of a circle, see here, then also C I will call center of the circle. Somebody will ask, where is circle? Circle is there. If I tell center of circle means it is complete. See, this is a quadrant. Continue, 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 all round, all 4 rounds. See, this way, all round here. Any circle will be formed. This is our considered one. C is the center. Here, this is the diameter. Of course, this is the radius. See here, actually not required. This is the radius. This is the diameter. So, in all the cases, radius equal to half diameter. Semicircle, you can see the diameter, you can see the radius. Quadrant of a circle, you write always see. When I do a problem, what I do? I write diameter equal to D. Diameter it is D, radius R, diameter you cannot see, it is equal to, radius equal to diameter by 2. Okay. This may, in future, I won't waste time every time now telling that it is center of a circle means not circle. A circle, if you complete everything all round, you get the circle. Okay, then, these are over now. Here, our purpose is to find moment of inertia about centroidal axis. Axis for both means, you can write here, for both semicircle and quadrant of a circle. Quadrant of a circle. Let G be centroid. See, for semicircle, see here, you write here, consider semicircle. Here write, consider quadrant of a circle. Consider semicircle, complete statement, consider quadrant of a circle. Little statement you have to write. Here, centroid G is here. See, it is symmetrical about YY axis. So, YY symmetrical. So, this way, centroid is exactly mid distance. See, how much from here? Same here. This is nothing but what? This distance is, you can either call, diameter is D. See, this is D by 2. This also D by 2. D by 2 or R. Or R. Or R. That is centroid this way. This way centroid, we already used so many times, we derived earlier, is in terms of diameter 2d by 3 pi or in terms of radius 4r by 3 pi. Centroid will be little this side, near. See, more area here, not that side. This is around 21%. It's not 21%, around 40% of this one. This is nearly 60%. Okay, that you don't bother. 2d by 3 pi, centroid near this side where area is more. If quadrant is there, centroid is there is no axis of symmetry. This way also 2d by 3 pi, this way also 2d by 3 pi. See, near this side, near this side. 2d by 3 pi, 2d by 3 pi or 4r by 3 pi, 4r by 3 pi. Centroidal axis x, x, y, y. Now I will tell you one thing. See, this all you write here now. Then this I will remove. For some, I wrote here. See, class, confusion. I will fully clear. Majority of people got confusion, especially for semicircle and quadrant. See, rectangle, triangle, circle, nobody gets confusion. But this semicircle or quadrant, so many has got confusion to understand what is how to decide my I about centroidal axis. So for that, what I will do is, I write something here now. See, that confusion I will remove now. See. You make one more note. After writing all these, when everything is over, now write confusion is there. He is explaining what is that confusion and he will remove it. See, first you write. When you write expression for moment of inertia, remember I about this axis will be pi d power 4 by 128. That is the expression in terms of diameter. Radius I will give later. Or if you want radius, it is or pi r power 4 by 8. If you write in terms of radius. 4 into 16. 8 into 16. 8 into 16 is 120. Pi d power 4 by 128. Or if I replace by r, diameter 2, and 16 by 128 is y confusion. 8, correct. Pi r power 4, 8. But remember, when you write I about this axis, it is, see here, pi d power 4 by 128 means people understand. See, circle is 64, it's half. So pi came here. But when you write I about this axis, you cannot write that way. It is most, I am writing most popular here. Next class I will give more details. Not next class, when I go to summary, I will give you more details for that one. I will give complete clarification at that time. But here also I will remove the confusion. The answer for I will be 1 minute, pi by 128 minus pi by 8 into 2d by 3 pi whole square equal to 8. Most popular version is, see, this I is, for this one I is, this is I about what? YY. I about XX, that is this axis, parallel to the base, is 0.00686. 68598. 68598 d power 4, or in the class later I will write 0.00. See, 685986. Almost throughout the world they are using 686 d power 4 this way in terms of diameter. And I will tell the reason. In terms of radius, or it will be shift store A, the answer is there, shift store A equal to into 16. 16, okay. No, shift store A into 16. 0.109757 times r power 4, or some people write point, see, they will round up to standard decimal here. 107 makes it 1.11 r power 4 is very popular throughout, everywhere. These are the popular. Even, but for us, when we do a problem in terms of radius, we never do the problem, correct? We never do the problem in terms of radius. Okay, leave it. This is the answer. Now, this is for semicircle. See, about one axis, it comes in terms of pi. See, pi by 64, 64 became 128. But here, it is some odd way. Okay, here what happens is, your I about xx, see, I'll put here now, and also equal to, both are equal, I about xx equal to I about yy equal to, it will be 0.034 299. 299 d power 4, or the most popular is 0.00343 d power 4 is the most popular used. That is what we are also using in terms of diameter, or if they want in terms of radius, it is into 16. 0.00 point, how much it is? Shift store A is how much into 16 is 0.111 something divided by 2. 0.00, it is in terms of radius 0.0054878. 54878 r power 4. Correct answer? I'll check it into 16. Point, no, 0.0034. What is the answer there? Because radius I don't remember. Shift store A is the moment of inertia. What is this one? I into 16 is 0.1 divided by 2. No, point not, only single not. See, I got confused, doubt suddenly. 0.054878. 878 r power 4, or the popular version is 0.0. So many people use 0.0549 r power 4, or some people even use 0.055 r power 4. Somebody will ask, sir, what we will use? We will not use, because why? We will always use in terms of diameter for solving problem. But I mean information. Now, lot of confusion comes. What is going on here? Why? How to decide? See, this is half that of the circle. About yy, half that of the circle. But about this axis, it is not half of the circle. But about this axis is half that of the circle. I will tell you later. Here, about this axis, 1/4 of circle. About this axis, 1/4 of circle. But about these two axes, some other way it comes, some decimals comes. It is not directly 1/4 of circle. Doubt will come. These all doubts I will clarify, nothing to worry. I am there to clarify. So you make a note when I put final result, and I'll derive the equation now. This all I'll derive it now. Once I finish derivation, when I give summary, then I will give complete clarification how to remember and how not to get confused. Wait. Now start moment of inertia for a semicircle about center of the axis. I already told you, see, center of the axis, I will do in terms of diameter now. Diameter equal to d. So, this distance is 2d by 3 pi. 2d by 3 pi. Whereas these two distances are exactly midpoint. So, d by 2, d by 2. Or radius r. I will do in terms of diameter. We want I about xx, I about yy. First we will do iyy. There is a reason. Ixx got some calculations are there. First I will do easy one. I about yy. Okay, start. This is the shaded part. I shaded this one. Note. First of all, we make a note here. The shaded portion is our semicircle. See, if you want, I once again shade here also. Okay. Shaded part. Now, before you go here, already derived earlier. What? For a circle, you write here. You should write circle, semicircle, radius I am not using now, and write here quadrant of a circle. quadrant. We already derived last time. What? I about this axis. See, no x, x, y, y. Here, make a note here. In already derived, I am not talking about centroid. See, centroid, I am not talking about centroid. I will only talk about center of circle. See, this is a diameter, this is a diameter. I about this diameter or this diameter is pi d power 4 by 64. Of course, for circle, that is nothing but ixx, iyy only. Whereas for a semicircle, see, centroid I am not marking. I about this base, you can call it base if you want, or the bottom edge here is pi d power 4 by 128. That is half of the circle. You got by integrating. This you got by 0 to 2 pi radian. This is by 0 to pi radian. This one later by 0 to pi by 2 radians. Whereas for a quadrant of a circle, about this axis, we got pi d power 4 by 256. Same answer here also. Why? Both are same. See, how is the quadrant here? Same way quadrant here. Okay. Okay, this is already derived. Right here. Now, what you do is, our purpose is I about yy for shaded portion. See, yy is here. Introduce same semicircle on the bottom side here, as per my sketch, bottom side, to get a full circle, for which Iyy equal to, see, pi d power 4 by 64, Iyy, about this axis. Now, the introduced semicircle is a mirror image of, see, is a mirror image of that semicircle. So, how is this semicircle with respect to yy? Same way is this semicircle with respect to yy, or I about this semicircle plus I about this semicircle is what? I for a circle. Therefore, you can make a note here. Therefore, I about yy of the existing semicircle, that is our semicircle, plus I about yy of the introduced semicircle, both are equal, and both are equal to what? Pi d power 4 by, both are equal. Therefore, each of them, Iyy for semicircle, only one side shaded, is exactly half of, see, the I for this is exactly half of I for this axis. Half of pi d power 4 by 64, that is pi d power 4 by 128. See, more and more clarification will be given later, or how to remember. That's the most important. When I tell the answer, people will believe. In the class also I have seen. But later when you go to application, confusion comes. I am there to remove confusion. Okay, this is for I about yy for semicircle. Leave it now. Now come to I about xx. Okay, now important, see. That is already there. I am not removing it now. It is already derived. See, where centroid is not considered. You make a note somewhere. See? You write in between. Refer already derived. Okay, now I about xx. To get I about xx. See. To get I about xx axis. That is right here. That is centroidal axis passing to, of course, centroidal axis means passing to centroid and parallel to this diameter or base, horizontal axis here. See, now, here, there is no symmetry. See, if you introduce one more circle here about xx, complete different. See here, you get some partial circle there, and see, they're completely wrong because you cannot divide by 2. See, if you make a note here, if xx is here, see, upper side is like this, lower side is this way. They are not same because center is here. See, you can make out here. If I hold here, if I introduce one more semicircle here, upper side, lower side, they are not a mirror image. Therefore, you cannot use that mirror image principle or symmetry principle like that. So, what you do is use parallel axis theorem. Parallel axis theorem. according to which, from which, right here, see, from which I about which axis? Any axis, see, I about, I will do one thing now, some name I will give here, base. I will call this as AB, base. You write one more sketch. This sketch you write one thing. Now remove that YY to avoid confusion. Okay, remove that YY. Okay, that is much better. C, center here, centroid is here. Okay, you one thing, parallax theorem. This sketch you write once again. Write again. To understand correctly, write again. Okay, now see here. This is centroidal axis passing to G. This is any axis. So, by parallax theorem, I about any axis, see AB equal to IG, here IG, moment of inertia about an axis passing through centroid and parallel to required axis, IG is nothing but your IXX. See, centroidal axis IXX here, IG plus area into H square. H is perpendicular distance from centroid to the required axis, H square. Now here, IAB is already derived. Right here, already derived here, see. Pi d power 4 by 128. Right here, we know that I about the 128. You write there. We know that I about base of a semicircle or about a diameter already derived, it is half that of the full circle equal to your IG, I use IXX plus area of the semicircle is pi by 4 is the area of a circle, pi by 8 is area of semicircle, pi by 8 d square into H square. H is 2d by 3 pi whole square or red color, okay. 2d by red color is better. So show that red color is used. See this distance 2d divided by 3 pi whole square, or therefore your IXX equal to, see here, x equal to, shift other side. See, this is equal to this minus that one. It is pi d power 4 by 128 minus, see, minus will come here, or moment of inertia about centroidal axis is always less than any other axis, because by centroid axis to some other axis you are adding. From some other axis to centroid if you are coming, you are subtracting. See, minus pi by 8 of d square into 2d by t by is 4d square divided by 9 pi square. Now I will do one thing now. See, or equal to, see here. 1 minute. I got two simplification, or equal to. Now here pi comes. Here pi is not coming. So you cannot take pi common. Therefore what people do is d power 4 here. D power 4 is already there. It is d power 4 times pi by 128 minus, see, pi square. So this is what? 4 divided by 8, see 4 here, divided by 8, divided by 9, this is pi square, divided by pi. This number, this you cannot remember, people will calculate. This will be equal to, when you calculate that number, see, pi by 128 minus 4 divided by 8 divided by 9 divided by shift pi. Calculator is not on. Pi divided by 128 minus 4 divided by 8 divided by 9 divided by pi. 0.00, this number is 0.0068 5981. 5981 time is this number. Therefore, IXX equal to, I will write the popular number is 0.00. Usually people write Third, three numbers sufficient here. 6, 8, 5, 9, 8 is 5, see 6, okay, actually sufficient. 6, 8, 6 d power 4 is I about xx. 686 d power 4. This is what people will use. Now, I will give one more equation, but I won't use it because make a note here, or right here, or one more thing. Suppose you require in terms of r. In terms of r if required. Then suppose required in terms of r, then that ixx equal to same number, point not, see. Okay, your one thing, same thing. How much? D power 4 is 2 times r power 4. 2 times r. What you do? Write d equal to 2 times r. 2 times r. You use this equation only. 2 times r power 4 into that number is point not 685981, or it will become whatever that number into 16. What number you got there into 16 is 0.10.975 7 times r power 4. R power 4. I already told it earlier. But which people most popularly use it as, they will take three numbers here. See, 7, this 9 will become 0, this will become 1. 0.11 r power 4 is very popular number. Okay, now one more thing. But first of all, this is what, see, usually everywhere, I will write the answer here. Okay, wait. Okay, I will put the answer here now. Then I will explain further. Therefore, final result is more and more explanation is there. Don't worry. Complete clarity will be given for you. Complete clarity. If a semicircle is there, see, of diameter equal to d or radius equal to r, remember now, for this one, centroid is here, G. If I take a light line here, this is your x-x axis, this is your y-y axis. This centroid is at d by 2 from here, or center d by 2 or r, okay, r equal to r, and this distance is 2d by 3 pi, or you can tell, or it is 4r by 3 pi in terms of radius. Then, see, somewhere here, I write here, I about xx is point, we will use in future, 0.00686 d power 4, whereas or you can tell, or point, where is the radius, how much it is? 0.11 r power 4, and this is this Iyy equal to pi d power 4 by 128. Check the camera once, because sometimes camera moves there. If camera moves there, not visible clearly. No, clear. This answer. Now, I will give, you make a note, this is what universally everybody is doing. But first of all, I don't like that 0.00686 or 0.11. If I would like to introduce some other way, but what happens is, suppose you get an examination, if you write that way, some people will tell, no, this is not there. See, people are there. They won't think that way. See, what I will do is, no, this Ixx, see, what I want, what I prefer is Ixx, Iyy same. How much? pi d power 4 by 128. No confusion. Ixx is, see, I will do one thing now. See, it is pi d power 4 by 128 minus pi by 8 d square into 4d square by 3 pi. Not 3 pi, 9 pi. 4d square by 9 pi square. 9 pi square. This already you got earlier. Then we simplified it as 0.00686. But what I want is, that is actually correct. I don't know why people are not doing it. I will still take pi d power 4 by 128 common. It will give a beautiful concept now. See, into 1 minus, see, pi by 128 common. Here, pi is there, 1 by pi square is there. You can see here, pi here, 1 by pi square. So this actually is 1 by pi. 1 by pi means I am taking pi outside here. Be careful. I am taking pi outside here. So you have divided once again by what? See, or, see, pi d power 4 by 128 I will take outside. Or I will do one thing before that to make it more clear. Minus, see, pi square is d square by 8 into 4 by 9 pi. D square pi. Where is it actually? Correct. D square by 8 into 4d square. 4d square. Correct answer. 4d square. 4d power. Not d. 4d square. What is this one? D square into d square. What is that one? That is d power 4. D square is d power 4 by 9. 9 not 9. 9 into 8. 72. See, d power 4 by 72. Pi and pi square is there. So I will do one thing. I should write only pi. Then I will do one thing. I will multiply by pi, divide by pi. I will multiply by pi, divide by pi, and then I will multiply by 128 and divide by 128. So that, see, this is for those who find difficulty. It will be pi d power 4 by 128 times, see, 1 minus pi d power 4 by 120 outside times 128 by 72 pi square. Is it correct? Let me check the number. Easy to check the number. How? 1 minus 128 divided by 72 divided by shift pi square equal to some number into pi by 128 is giving, no, some other number is giving pi d power 4 by 128 minus pi by 8 is pi by 8 d square into 4d, 2d by 3 pi whole square is 4d square by 9 pi square, or it is pi by 128 into d power 4. Oh, 1 4 is missing here. See, what happened? 1 4 missing, correct? Yes, 1 4 missing here. Yes, see, 1 4, actually it's not 128. Already 1 4 is there. See, into 4 is there. I write that 4 here. 4 here. Then okay, into 128 by 128. Nobody is doing it. Then it will become 128 into 4 is 512. 512 by 72 pi square. 1 minus 512 by 72 divided by shift pi square is some number into pi divided by 128. 0.00686, correct. Now you can do one thing. See here. R equal to pi d power 4 by 128 times 1 minus 512 by 72 is exactly 64 by 9. 64 by 9 pi square. I think correct answer. 1 minus 3. I will check the answer now. 1 minus 64 by 9 divided by pi square, answer divided by 128 equal into pi. 0.00686, correct. Okay, now what if you write this way, but I won't write in while doing problem, I won't use it. It is my personal idea. So if I am free to write it, I will write Ixx equal to C. Pi d power 4 by 128 into a reduction factor, or I will write here 1 minus 64, even 64, or you can do one thing. 64 is 8. 8 by 3 pi whole square. I write this way. 8 by 3 pi whole square. This is the equation I will propose. See? What I will tell anybody is, again check it, 8 divided by 3 divided by shift pi whole square into minus 1. Minus 1 is so much. 8 square divided by 9 divided by shift pi square is 0.72 into minus 1 plus 1 into shift pi by 128. 0.00, or this number will come, see, 1 minus 8 by 9 divided by pi square, 8 by 9, okay, 8 by 3 divided by shift pi equal to whole square equal to, why is calculator giving that way? 8 by 3, 8 by 3 divided by shift pi equal to square. This number is 0.720506. 720506. Now if you complete it into minus 1 plus 1 into pi divided by 128 is 0.00686, correct. Okay. Now this is more, see, if you use, now you can do one thing. See, don't write actually. I prefer this to number as what? If I am free to universally, I will propose this one. I will tell best is pi d power 4 by 128 times, see, I will tell 1 minus bracket, this way, bracket 1 minus 8 by 3 pi whole square, and this number I will tell will come approximately 0.720506. No, that what number? Full number. Is it full number 0.72 or partial number? 1 minute. 8 divided by 3 divided by shift pi equal to square, into minus 1 plus 1. It is coming 0.279, not 72. This number is coming 0.279. This is coming 0.72. 27949. 49 is coming. Now see, but don't use it actually. No, you go for this answer and this answer only. Don't go for this one. See, now it is a beautiful logic is there. What I can explain is, you want I about YY? Yes. Is it symmetrical? Yes. Is, if I introduce one more semicircle here, will it be full circle? Yes. Then it is half of the circle. Yes. Pi d power 4 128. Now, is it symmetrical? No. If you use one more semicircle here, will it be half a circle? No. Then parallax theorem. From base to here you have to come. Base is symmetrical. See, symmetry means what? For base, you can put one more semicircle. Then answer is pi by 128. Because of the shifting here. See, when the axis shifts, when the axis is centroidal axis and the axis shifts from centroid, moment of inertia increases by Ig plus A square. When the axis from outside comes to centroid, moment of inertia decreases. Decreases by, see, how much? 72.0506% or only 27.949% of the See, I about xx is only 27.949% of Iyy. That is, if symmetry is there, then whatever I is there, if it is not symmetrical here, it is only 27.949%. That is much more clarity, but nobody wants it. So I only told for information for you. You remember this one for even while solving problem also, I will use this one and this one only. I will not write because suppose in examination, if somebody writes this way, there are people who will tell, what is this one? What is this? Where he get it from? Such terms are not there. If they use their brain, if they take a calculator and calculate, oh, they will tell correct. Then they will start thinking what he has done. Then somebody with a mathematical base, he will tell, oh, correct. He is connecting Iyy to Ixx. Or how much is Ixx, how much percentage lesser is Ixx compared to Iyy, because of the what? Centroidal axis is not passing to center. So since it is shifted there, moment of inertia will reduce by what percent? But people are not that much open-minded. They will tell, their answer will tally, still they will tell, see, question mark, what is this one? Okay, why? Leave it. I told only for information. So what all I told, you understand and leave it. So you just stop. When I wrote this answer, stop. I told what I prefer is my preference. I told for you so that you should know how concept oriented I am. Okay. Now lastly, quadrant of a circle. Now lastly, moment of inertia about centroidal axis for quadrant of a circle right here. Diameter d, radius r, 2d by 3 by 2d by 3 pi, everything is explained. Let us first find Ixx. See here. But before you find Ixx, make a note. For a quadrant, I about the base is, this IAB is pi d power 4 by 256, already derived. Make a note. Now, one more sketch here. See, this is xx, this is AB. Use parallaxis theorem. Then, I about any axis is IAB equal to I about centroidal axis, that is IG, Ixx plus area into h square. I about AB is pi d power 4 by 256. Already you got it here. IG is Ixx plus pi area for semicircle is circle pi by 4d square, semicircle pi by 8d square, quadrant pi by 16d square into 2d by 3 pi whole square, or equal to Ixx equal to pi d power 4 by 256 minus pi by 16d square into 4d square by 9 pi square, or d power 4 outside into pi by 256 minus 4 by 16 by 9 divided by pi is not pi square, pi and pi square is there, one pi will cancel. This will come 0.0034299, or very popularly people take it 0.00343 d power 4. That is I about xx. Then write I about yy is equal to I about xx. See, no calculation. See here. How is the arrangement here? Same is arrangement here. You turn it, nothing will happen. Nobody will ask you why. Because observation, see, whatever you got I about xx here, see, is I about yy. Therefore, Iyy also equal to 0.00343 d power 4, and both of them you can make a note in terms of radius. See, in terms of radius if required, equal to, what is the number there? D power 4, you make what? Substitute, replace d equal to 2 times r. So it is 2r power 4 into that number. How much that number? Into 0.0034299, or this will become whatever the number is there, multiply by 16 into 16. 0.0054 0.0054878. 878 r power 4, or people usually take 0.00549. 55 they take. Some people take 55. So many people they take 0.0055. Anyway, we will not bother because we will not solve in terms of radius. 0.00 not single knot. Point naught. Only point naught. 54878. 54878. Okay. Now, very important closing part of the class. See, closing part. See, you make a note here. This everything is remote now. Nothing required. Closing part of the class. Right here. Semicircle. Semicircle. D is the diameter. R is the radius. Radius. Of course, radius equal to diameter by 2. Semicircle here. Centroid is here. Centroid is here. G. This is x axis. This is y axis. Where is y? Y from here is at 2d by, it's bigger, xx. 2d by 3 pi or 4r by 3 pi or 4r by 3 pi. And this is exactly center, diameter by 2. Diameter by 2, or you can tell equal to radius here. First y, see. Iy is pi d power 4 by 128 in terms of diameter, or pi r power 4 by 8 in terms of radius. Here, Ixx 0.00656 alla 656 correct answer. 656 I think 656 I think it is. Again I forgot the number. See, I am not good in remembering by hearting the numbers all. Anything which is thumb rule I am weak in remembering. Shift store A 0.006 not visible. 0.00 it's not 656. 0.00 see 686. Okay. IS 456. Okay. 686. See, one small number missing. 0.00686 d power 4, or some people will tell 0.11 r power 4. Okay. Over. And this is semicircle. Quadrant of a circle. Right here. You write quadrant of a circle. D you cannot see. D is the diameter. R is the radius. You show a quadrant here. These are not required now. This way. Okay. Centroid is here. This is the x axis. This is the y axis. Y axis. If you want this distance, it is 2d by 3 pi. This also 2d by 3 pi in terms of diameter, or it is 4r by 3 pi. This also 4r by 3 pi in terms of radius. And then that's all. Center is here. Directly single line. I about xx equal to I about yy. Both are equal to 0.00343. Correct? 343. 343 d power 4, or some people they write 0.055 r power 4. This is summary. Now important. That is what important now. I will tell you correctly how to remember. Not this way. I have got my own trick of telling it. Later, when you require I about y, you will tell immediately, sir, pi d power 4 by 128. About this axis, sir, it is that number, 0.006, I say, forgot it now, 686 d power 4. Quadrant, sir, both are 0.00343 d power 4. How I will make you clear. So, those students in front of me, when I take the class, after I explain, when I ask, they will tell immediately answer. Why? I will tell some concept, not now. That I will tell in the final summary. Or there is one class where I am giving complete details. Moment of inertia for rectangle, triangle, circle, semicircle, triangle, 3 types. What usual general triangle, isosceles triangle, right angle triangle, and then circle, semicircle, quadrant. There full one around 2 hours class. Full I will explain. At that time, for each and everything, I will give you explanation. And here, I will give complete explanation how to remember it. Okay. So next class will be this over now. Yes, the most important parallax theorem, thorough explanation. Most probably, next class I will make it fully clear, parallax theorem. Earlier I made clear, but next time full clear. Okay, thank you.